All right, so what are we going to do next? We need to look up the calculate the specific heat of Sapphire. Okay, so Sapphire, like I said, is used as your standard for DSC heat capacity measurements. And the values of the heat capacity of Sapphire is well known over a wide temperature range. Okay, and so actually I gave you the numbers that I've already looked up for you in the second sheet. So if you look at your second sheet, right here, Sapphire standard. What I've done here is I've given you a table of heat capacities that I've looked up for Sapphire. What do we have here? Heat capacity from 56.85 degrees to 176.85 degrees. So it ranges from 0.837 to 0.9975. That's a specific heat of Sapphire. But we need to be able to calculate what the specific heat is at 60, 61, 62. So what we need to do is get an equation that we can use to do that calculation. And so what we're going to do is we're going to fit this data to a polynomial, a second order polynomial. Notice here in the handout, shows you what it should look like, okay? And so let's do that. We're going to let our specific heat be a second order polynomial. If you look at the graph here, by the way, that's, it's almost like a straight line, but it's not perfectly straight. So let's just fit that to a quadratic polynomial to get a better fit. Okay, so what we do here, we're going to say the specific heat, we're going to fit that to the equation AT squared plus BT plus C, where A, B, and C are constants. We're going to put A, B, and C over here. Actually, it's pretty simple to do it on the chart. You just go right click, okay, add trend line, and our trend line is going to be a polynomial trend line of order 2, second degree polynomial. And you can display your equation on the chart, and you can see it's right there. Okay, now if you want more sig figs there, you can, what you can do is you can highlight it, you can right click on it, and you can say format trend line label. You can say the number, I want that number to have more decimal places. Let's make it scientific notation because one of this is very small. And then you want 5 decimal places, for example. You can see
second order polynomial trend line.
Yes. So you can see those are all as many sig figs as you want in there. Okay. So you can use that. Or you can use these also. You can get these numbers using the Linus function. So how do you do the Linus function? Let's do the Linus over here. The first thing we need to do to be able to do the Linus is tabulate your temperature and T squared here, because those will be your X values. So the temperature for the first data point is this number, right? A4. And T squared would be this one squared. And you can just copy that down. Okay, so you have a table of T and T squared, 2 columns, one for T, one for T squared. So you can do a Linus. So how do you do a Linus? Since we have 3 parameters here, A, B, and C. C is the intercept, so the C will come out in the third column. Okay, and A will come up in the first column, B will come up in the second column. So let's go ahead and highlight 3 columns and 5 rows. One question?
No, it's just T squared on the second.
Yeah. So 1, 2, 3, 3 columns. That will give you the constants A, B, and C. And then 1, 2, 3, 4, 5 rows. So type equals Linus, open parentheses. You have to tell it what the Y values are. What are our known Y values? It's the specific heat of the Sapphire, comma. What are our X values? T and T squared. So you have to highlight the 2 columns right here, D4 through D16, comma. Do we want it to calculate the intercept? Yes. Okay, B is the intercept. And
True. And then
That's
true.
actually C here. So true. And then we want statistics, so hit true, close parenthesis, and then Control Shift Enter. And let's compare those two numbers, the one on the chart and these. So what is this? Minus 3.37 times 10 to the negative 6. That's the coefficient of x squared or t squared, right? What's the coefficient of t? bt. So this is your a, right? So a t squared. So that's equal to a is that one. I'm gonna put that in J1. Where's my b? 0.002196, 2.1196 times 10 to the negative 3. That's what that is. So this is b in our expression. So this is equal to b. And C is 0.728356, 0.728356. So that's our C. This is C right there. And the uncertainties in A, B, and C are down here, okay? So let's calculate our specific heat for 56.85. Let's just make sure that these are consistent. How do I calculate this? This is equal to
A.
$. I put a dollar sign on it because when I copy it, I want it to stay as J1, right? Times t squared. I can use this t squared or I can use that t squared. Which one do you want to use? That one. Plus b, again, dollar sign, right? Since to copy it, I don't want to change it, times t, which is d4, right? Plus c, again, put dollar signs on it. So 8373 versus 8378 is pretty close agreement right there. Okay, 0.9975, 9970, 9875 is almost exact. 9845, 9848, so pretty good fit. Okay, so now we have A, B, and C, which you can use to calculate the specific heat of sapphire from 60 to 150 degrees over here. So what's my formula going to be for this one?
The same formula as
So it's going to be A t squared. So I'm going to point to A. So I'm going to go to the standard sapphire sheet, point to A. Okay. And then hit times. So asterisk times, and then go back to data analysis times 60 squared, right? B10 squared. See that? See what I did there? So it's the Sapphire standard sheet, okay, J1 times the data analysis sheet B10, right? But this J1, what should I do with this J1? If I want to copy that, I don't want that to change, right? So I'm going to say F4 there, $J, $1. Okay, B10, when I copy it, I want it to change to B11, B12, and so on, so that's fine. So J1 times B10 squared plus, and then I go to the Sapphire standard sheet B right here, which is J2 times, go back to the data analysis sheet, B10 again. And then again, this J2, I don't want them to change when I copy it, so I'm going to put dollar signs on those. Plus, finally, J3, right? Sapphire standard J3, cell J3, and go back to data analysis. I have it right there. And that J3, when I copy that down, I don't want that to change, so I put dollar signs on it. And that's, oops, what doesn't it like? Oh, the second one, B10 squared, B10 plus J3. What's wrong with it? Is it is J, right? What happened? You're getting,
I know.
you're getting errors too?
Sapphire standard.
Oh, the last.
When I-
Oh, okay, this last one right
when I
here.
switch pages every time I'm.
Yeah, you had to put the next math.
Okay, so delete that one, go to Sapphire standard, J3. Enter. And now I have to fix that because I want that to be, I have to have dollar signs. There, it works now.
Yeah, give me 1 second.
All right.